It gives me great pleasure to introduce our first presenter, who is a globally recognised name in the diabetes online community, not only in the DIY community, but she's also one of the founding members of the DIY artificial pancreas system. And it's usually very rare that we have such a world star of the DOC in Ireland. Dana has come to us from Seattle, and she is now going to talk about the what, the why, and the how of DIYAPS. Great. Thank you, Dana.
Thank you so much to Grania and Shane and everybody who put this on. I came by way of Seattle via Denmark and Scotland on my way here. So I'm mostly over the jet lag, which is great. But thank you so much for having me today. I really wanted to help people in Ireland really understand, where did this APS stuff come from in the DIY community, and recognize that how we've developed matters, because we're influencing also the commercial development of APS. So even if you decide at the end of the day or in the future DIY is not right for you, that's absolutely okay. The point is that we have choices as people with diabetes, that we get to design solutions that work for us. But I always want to contextualize with the thing that we seem to overlook when talking about diabetes, and that is the fact that diabetes is really, really hard. Because when we're diagnosed, we're given some basic settings. You may be given an insulin pen or a syringe and a vial of insulin, and you're sent home to figure it out on your own. And you're given the basic information to kind of get over the first couple of days, but oftentimes we don't talk about the fact about how complex diabetes is. Insulin, even if you inject it, doesn't work instantaneously, right? It might peak in your body in 60 to 90 minutes. It lasts in your body for several hours. And as we mere humans are lazy, or we sleep, or we work, it makes it really hard to keep track of the details, especially what did I do 4.5 hours ago that's affecting me now, and then you've made a lot of other decisions since then. And so that's why so often our blood sugar readings or our CGM graphs looks like this, because not only is insulin not a perfect instantaneous drug, there's also many other things that go into affecting our blood sugar. There's things like jet lag and stress and excitement that might send you up, and things like exercise and stress and excitement that also might send you down. How do you measure the impact of jet lag on your blood sugar? You can't. How do you calculate how stress or excitement, how exercise one day and then the next is going to impact your blood sugar? That makes it really, really hard. And the other frustrating thing about diabetes is, yes, we have tools. Many of us are fortunate to have access to insulin. Many of us can either self-fund or get access to CGM devices or insulin pumps. But these tools are not perfect, and they're not interoperable. I remember so clearly on the first date with my now husband, I pulled out my insulin pump to give a bolus at the dinner table and give him a chance to ask about diabetes. And he's like, I've heard about the CGM thing. Do you have one of those? And I said, oh yeah, I've got that right here too. And he said, but why do you have two devices? Why doesn't the blood sugar reading go to your pump? And I said, well, because they're made by different manufacturers, duh. And as somebody who was not in diabetes and not in healthcare, that answer is so normal to us, right? That's a duh answer. Of course they don't talk to each other. It's diabetes tech. But to him, people outside of healthcare and diabetes, they're like, that's crazy. In consumer technology, you make the data go from to whatever device that you want. And it's not just frustrating in terms of having to carry around separate devices. It also means our results look like this. And the reason I show this picture is because when my doctor asked me to bring in a week's worth of my data, I said sure at the time, and then at the next appointment, I went to figure out how do I get my data to them. And at the time, I had a Mac laptop. Does anybody here have a Mac? Congratulations, if you were like me in 2013 in the United States, you could not get access to your data because the FDA-approved software was for a PC. So what did I do? I pulled the receiver out of my pocket, pressed the button, went to the 24-hour screen, pulled my phone out, took a picture, emailed it to myself, copied and pasted it into Excel, printed this out, and handed it to my doctor. And my doctor was like, okay, great, thanks for sharing your data. And I was like, come on, y'all. This was terrible. And the other big problem that I had with these devices that everybody told me was just my problem, but if you look at Google, there's like 40,000 search results for how do I make my CGM alarm louder. I'm the world's best sleeper. So I would sleep through my CGM alarm, and I lived by myself. So I was very, very afraid of what would happen if I did not wake up to a CGM alarm. And that's what brought me into DIY, was this frustration that turned into fear of living by myself and going to sleep at night, living with type 1 diabetes and knowing that I was at risk of dying in my sleep. But what could I do? I called the manufacturers as a good patient, did give them my feedback, please make the alarms louder. And the response I got ranged from, it's loud enough for most people, to we're working on it, it'll be out in the next version. 5 years later, it still wasn't out, so you can see how that went. But there was nothing I could do, right? I'm just a patient. I was not, a medical device engineer. I didn't work for these companies, so what could I do? And a couple months after I met my boyfriend and had the conversation about how diabetes devices were terrible, but I had this idea, if only I could get my data, which I couldn't, I would make a louder alarm by sending the data to my phone and doing all kinds of stuff. But again, couldn't do it because I did not have access to my data. But something changed in later 2013, thanks to social media. I'm very active on Twitter. If you're tweeting, that's my Twitter handle. And I saw a tweet by a gentleman named John Kostick. And he showed a picture of how he had plugged the receiver in to a computer and reverse engineered the driver to pull the data off in real time every 5 minutes. And he sent it to the cloud for remote monitoring. But a light bulb really went off for me, and I said, ooh, if he would share his code with me, I could take it to the cloud and then down to my phone and make a louder alarm. I could solve my problem of being afraid to go to sleep at night and not being able to hear the CGM alarm. And that's really where my first encounter with open source was. This idea of people freely sharing ideas and code. I'd been familiar with the diabetes online community for years, and this idea of people sharing, but sharing code, that was something new and totally different to me. But he was kind enough to share his code, and that enabled me to build my first system that we called DIYAPS. Totally jokingly, the do-it-yourself pancreas system, even though it was just an open loop that would take data from the CGM, send it to the cloud, and send a louder alarm to my phone. But we progressively added features like this really terribly ugly web page that works really well if you're low at 3 o'clock in the morning, because you can see here's what your blood sugar is, here's what it's going to be, and here's the action you need to take. So instead of having reactive, you're low, you're high, you're low, you're high alarms, this allowed me to switch to get predictive alarms. You're okay right now, but you're going to be high in 72 minutes. You're okay right now, but it looks like you might be drifting low, but if you do lower insulin now or eat carbs, you won't actually have a low. So this was absolutely revolutionary for me, and we now know that to be an open loop system where I as a human was still taking action, but the system would give me these predictive alerts and alarms, and it worked really, really well, and we were wondering, how do we share this with other people? Because I was helped by John and other people as I talked about this, we added features to the system, we had an algorithm that would predict the future. It was really, really cool, and there was nothing else out there. And we were told, don't worry, an artificial pancreas system is on the way. 2 years, it'll be there, right? And so a couple months later, as we talked with the diabetes community, we met somebody else who was instrumental to the story of APS. His name was Ben West. He had been trying to figure out, how do I trust the insulin pump when it tells me that it's giving me my dosing? So he spent a lot of time looking at the communications with the insulin pump. And it turns out you can not only read data from these older models of insulin pumps, you can also write commands like temporary basal rates. So the light bulb went off again that if you take the same CGM that I had, where we could now get data, and now we can get data from the pump, you can stick a computer in the middle and make a closed loop. And closed loops in diabetes work really, really well because in manual diabetes, the human has to look at the CGM, has to look at the pump, or has to look at the injection data, think about the future, think about the insulin activity curves, decide what to do, and do that, dozens or hundreds of times a day? And it's exhausting. In the course of this couple of 4 hours, you're probably thinking about your blood sugar, your diabetes, dozens of times if you're not on a DIY closed loop. So the beautiful thing about automated insulin delivery, or a closed loop, or an artificial pancreas, whatever you want to call it, is that you put a computer in the middle. So the computer looks at the blood sugar reading every 5 minutes when it gets a new data point. It looks at the insulin pump and says, what's happened? It knows about the insulin activity curve and the 60-minute spike and the 7-hour duration of insulin. It thinks about what to do, and it tells the insulin pump, give more or less insulin. And it does it over and over and over again, every 5 minutes. It's thinking, doing the math, and deciding what to do. So what does that computer system look like? It must be this, big behemoth thing, right? No, it looks like this. Oftentimes, people don't even realize I'm wearing my computer on my hip. And the first systems use these external computers and radios because you had to bridge the radio communication with the pump. There's now multiple DIY systems. Adrian and Katerina will talk about those. But this is what the first system really looked like. pump, CGM, and a small computer and radio board that looks like this. And then you can see on the right the Nightscout graph that I've got displayed there. If you're not familiar with Nightscout, it's a great open source remote monitoring tool. You can not only see the blood sugar data, which is the green line, you can see the purple prediction line into what's going to happen in the future, but you can also see the blue line up and down, how much work the pancreas is doing in order to keep that green line relatively flat in my target range. And people always say, well, how well does this thing work? Can it really do that much better than you? And I say yes, because if you look back at what I had before, this was my week where I knew my doctor would be looking at my data. Every night I took a picture of this and I was like, this is the best I can do. 40-50% time in range. High, low, high, low, high, low. I am educated in diabetes. I tried really hard. I paid a lot of attention. I had a pump and a CGM, the gold standard of diabetes care. That was the best I could do. So what happened in 2014 when we closed the loop? With a really simple algorithm and just throwing a computer in the middle of the pump and the CGM, the first week, this is what I got. This is what a closed loop can do. It is way better suited to the job of being a pancreas than we humans are. The computer is the right tool for the job instead of we humans. And so I obviously really liked this. I woke up every morning with these lines, and I wasn't going to sleep afraid anymore. It was just drastically different quality of life for me. Even within a couple of days, the fear of going to sleep dissipated. And I thought, I can't distribute this because that would be distributing a Class 3 medical device, which is frowned upon in the US by the FDA and other regulatory bodies worldwide. But we have to get this technology out to more people. How do we do that? So we decided to open source it. So this is not something that you can buy. You've never been able to buy it. It's not distributed. There's no organization or company behind it. But it's people like me and Scott and Ben and others who have built these systems who've said, let's find a way to share it with other people. And so that's where the name OpenAPS came from. It stands for the Open Source Artificial Pancreas System. And it's really about how do we share this technology and even the knowledge of how to build this technology globally. So anybody who wants to choose it can choose to use it and do it as safely as possible, benefiting from the knowledge in the community and the lessons learned of years of developing the algorithm and years of developing the safety mechanisms. Because we're the people with diabetes, we absolutely care about safety. We did this because we think this is safer for us, those of us who choose to use it. It's safer than manual diabetes. So we have a plain language reference design that you can read along with the code that explains what this system is. It's automated insulin delivery, and what the safety mechanisms are, both in the hardware that you can set on the pump and the software, how you can build it, how you can change it, how we deal with unexpected data, like what happens if your pump site falls out, what happens if your CGM falls out or goes to question marks, or somebody steals your pancreas. All those things we planned for and we designed for failure because we know it will happen. It's not if it will happen, it's when it will happen. So we absolutely designed for that. And we designed to know that the system is going to have problems. It might run out of battery, whatever. So we're always sending temporary basal rates to the pump that if the system breaks, at the end of the temporary basal rate, originally for 30 minutes, it expires and it goes back to the gold standard of care, which is your standard dumb insulin pump, right? So we designed for safety, we designed for it to fail. So if you ever want to go look at the reference design for it or the code, all of this stuff in the community is available open source. OpenAPS.org is a great place to start for that reference design. It'll point you to the documentation and the code online. But people often ask me, okay, that's you, that's nice, but really, is anybody else doing this? And back when I first started, people were really surprised to see the numbers in the community. First there were a dozen, then there were 40, then there were 100. Now, at a very, very, very conservative estimate in the community numbers worldwide, there's at least over 1,000 people using it. And this is significant because when you estimate people who are using it either overnight or during the day with these very conservative numbers, we calculate that there's over 11 million hours of experience with closed-loop technology in the community. So you can imagine that we have learned quite a lot. And if you look at a lot of the clinical trials that are submitted for regulatory approval, the pivotal trials, like the big final trials, many of them have something like 150,000 hours of data. The community has a lot of experience too. And so the beautiful thing about open source is it's not just allowing individuals to use it, which is absolutely true, but it's licensed so that companies can use it, academic researchers can use it. And so one of the things that we've done over the last couple of years is not just how do we help individuals use it, but how do we capture the knowledge from this community. And so Katarina will talk a lot more about research, but just at a high level, we do have studies. The results that I'm getting, they're not just me. people are getting better A1C, better time in range, reduction in time spent high and low. But it's not just about better A1C. One of my favorite stories about how OpenAPS works or DIY closed loop works for somebody is actually a parent of a child. And Jason Whitmer is an ICU doctor. His son has type 1 diabetes. They built OpenAPS a couple years ago. And his wife, Jason's wife, Katie, is a school nurse that works in the system. So she was able to quantify the school nurse visits for their son. In 4th grade, he went on a regular basis to the school nurse, before lunch, before PE, whatever, 420 times in the school year. And if you've got a child with diabetes, this is probably like, yeah, of course, this is what you do with a child with diabetes. They've got to go to the school nurse, et cetera, et cetera. But a lot of that is because there needed to be a lot of supervision. There were a lot of things that the school nurse had to do. However, after they implemented OpenAPS, 6th grade, 5 visits to the school nurse. Can you imagine how much time spent in the classroom is saved, time spent with peers, lack of distraction due to diabetes? It gives me chills every time I share that, which is why I share it. Because whether it's about the A1C or the time in the range or the peace of mind for the child or the adult or the parent or the family members, there's so many ripple effects of having the technology do the heavy lifting and the dirty work of living with diabetes. And it's not super complex rocket science. It's really basic. Every person with diabetes, or every person in this room, knows the basic algorithm of APS. What do you do if your blood sugar is going to be above target? You give more insulin. What do you do if your blood sugar is going to be below target? You give less insulin. That's the basics of the algorithm that we train the computer to do. And yes, we take into account the insulin activity curve and map it out in the future. And these are just a couple of examples of visuals of what the system will do. For example, if you're predicted to go low sooner, but high later, it'll be like, yeah, you're going to go high, but I don't want to give more insulin now that might contribute to a low. So it'll back off the insulin. And I know Thomas will show a great graph later showing you exactly how the system does this every 5 minutes. Every 5 minutes it's drawing this map and deciding, is it safe to give more insulin? If in doubt, it's not going to do anything to cause a low. Because again, safety first. We want to prevent hypoglycemia, but we also want to lower highs. So if you're going to be above target, it will give you more insulin. And that was the basic algorithm that I started with now 4.5 years ago, and it worked really, really well. But in the DIY community, when we see something that's like not quite perfect, we want to keep trying to fix it and make it better. And so we've actually added a lot of advanced features to these systems over the last couple of years. We've added features like auto sensitivity to OpenAPS in particular that looks back at the last 8 to 24 hours and says, are you more sensitive or more resistant than your settings normally are? So that if you are dealing with menstrual cycle, sickness, you ran a marathon and you're now super sensitive, or you broke your ankle and you're now not walking around as much. There's all these reasons why your body's needs for insulin might change. And it's really hard for us humans to pick it up, especially on a short time interval. Is it my pump site? Is it the menstrual cycle? Is it the exercise? We don't know. And autosensitivity doesn't care why. What it does is it looks back and says, you know what? You were predicted to be here and you were running consistently below target. So let's adjust your sensitivity accordingly, redo the math based on this, and give you less insulin. And so once autosensitivity came in, this took hybrid closed looping to a new level because the person didn't have to do as much work when you realized, oh yeah, this is my 5th or 7th day of a pump site, or this sensor is getting wonky, or my insulin may not be as effective. Whatever the reason might be, if you're running more sensitive or more resistance, the system can compensate in real time. And also, if you know something's going to happen, you can tell the system, I'm about to exercise, set a higher target. Or I'm about to eat, set a lower target and get insulin activity going. But we also recognize that this system does math based on your starting settings. And it was very common for people to come in the community and say, yeah, I haven't changed my pump settings since I went on a pump 10 years ago. And their body might have changed a tiny bit since then. And it's really hard for us humans, coming from manual diabetes to automated diabetes, to be like, no, my settings were working. And they were, but it was kind of like a house of cards where they were propping all of each other up. And so the system can't do as good as it possibly could. So we actually built a tool to help people evaluate their settings, and that's called AutoTune. And it was built inside the closed loop, but we realized how needed it was that we turned around and made it available outside of OpenAPS. So anybody right now can actually go to bit.ly/AutoTuneWeb. If you've got a Nightscout profile and you've got your CGM data, boluses, any basal treatments, and carbs in there, you need about a week's worth of data for really good results. But if you pop in a week's worth of data, you'll get a report that tells you your basal rates are here, and you might want to think about them being here. Your ISF is this. You might want to think about changing that ISF. I saw a thread yesterday on Facebook where somebody was asking about AutoTune, and I'm biased, I helped develop it. It doesn't work for everybody. Go with your gut. But it was really interesting to see people with long time, like 30 years of diabetes. Somebody commented and said, I knew my ISF was 32. Knew it, open loop, closed looping. I don't know why it was telling me that my ISF needed to be 54. It's 32. I changed it for one day, and the results were drastically different. Like my highs came down faster. I didn't have as many lows. There weren't as many bumps. So you might want to think about running this if you are not super confident in your settings. And it's also super common for people to switch into an automated closed loop system and have to change your settings. Even if you were doing great in open mode, chances are if the computer's making 288 decisions a day compared to your dozen, it's better to have the slightly different precise numbers. So what does all this do? Well, for me, having all of these advanced features and access to this closed loop system means that I've spent the last 21 months without bolusing for my meals manually. So I will do a meal announcement because I can just press a button on my watch and say I'm about to eat 60 carbs, 80 carbs, 20 carbs, whatever, and the system will take care of my meal dosing. And when I started doing this, I expected my A1C to rise a little bit. And my goal was actually to prevent post-dinner lows because I would walk to dinner, eat dinner, bolus, walk home. My digestion was slow from the walking and my insulin would go faster and I would have some lows. That was like my one period of lows. Like once a week, I'd have a little post-dinner low. I was like, well, maybe if I try these advanced features that we built, maybe I could get away without bolusing and I would reduce the lows, which might mean I go a little bit higher. My A1C stayed the same and I reduced those lows. So this system does better than I do at figuring out mealtime boluses. And there's also people in the community who do it no bolus and no announcement. Not everybody will want to do that, and it's not the first thing that you start with, but my point is, we often think about all of these systems as the same. They're all hybrid closed loop systems. You have to bolus, you have to carb count, you have to get everything right in order to get the good outcomes. No, if you look at the JDRF kind of like six phases to APS, most people think we're all at 4. The first commercial system, all the DIY systems, those are kind of a stage 4. They're hybrid. The human still has to do a lot of work. It's not that great. But I think in DIY, many of us are actually hanging out in phase 5, which is we do very little. We keep our pump sites in, we calibrate our CGM, we carry the pieces with us, but for the most part, these systems can do 95%, in my opinion, of the heavy lifting of diabetes, which is really good for when real life happens. I've had the flu. My nephew gave me and 16 other adults norovirus at Thanksgiving, which was super unpleasant. Jet lag, traveling, training for a marathon, sitting on my butt for 3 months because I broke my ankle by falling off a mountain. The system has kept me at the same A1C, the same time and range, everything with this. And as we've progressed, I've done less and less. I stopped bolusing for my meals. Sometimes I don't announce my meals, and I'm able to get the same outcomes. This technology, even really, really simple, is so much better suited than us at doing diabetes. And that's why I get really frustrated when people say, yeah, but you're not a doctor. You're not an engineer, right? Like, who are you to think that you could do this, right? Like, that's not your job as the patient. But the reality is, as soon as you're diagnosed with diabetes, no, your day job may not be that of engineer or scientist or whatever, but when you're handed that vial of insulin, you become an engineer for your life. You become a scientist who has to do experiments to figure out how does it work for you. So I always talk to people in healthcare about the fact that we can't let healthcare, and especially in diabetes, fall into the patient syndrome trap. What is patient syndrome? Well, you're probably familiar with imposter syndrome, where you feel like everybody around you knows everything and you know very little. Patient syndrome is kind of the same way, where people assume that patients know this, and healthcare providers and healthcare industry, they know way more than patients. Patients don't know very much. The reality is, patients know a ton of stuff. We've figured out stuff we've had to in order to stay alive and make this work for us. And it's not just about what we've learned, but it's about how we've gotten there. If you think about the way commercial systems get developed and brought to market, they can't just come to market with a wheel if they're trying to sell a car, right? You've got to wait, have the car, do the testing, get it approved, and great, they have to do that. But a car is a solution for a problem, but the car is not the problem. The problem is, how do I go from point A to point B faster? Preferably without walking, because I broke my ankle and it still hurts to walk. So you look around and you say, hey, I don't know how to build a car, right? But here's a block of wood and some wheels. I can make a skateboard. Skateboard would be a little bit easier, a little bit faster. And then somebody else comes along and says, hey, that's a skateboard. What if we add a steering to it, then you'd have a scooter? Cool, now we have a scooter. And you progress, and you progress, and you progress, and you end up with a car, and then a self-driving car, much quicker, and you've learned more about the mechanics and the physics and the motion and all this stuff along the way. And that's the point of DIY diabetes, is that we've learned so much. And whether you choose to DIY again or not, that's okay, but I want you to have choices, and that's what I'm so pleased with in the last 4.5 years, is that how you want your CGM, how you want your pump, if you want an APS or not, choosing to wait is a choice now, instead of saying we have to wait for a louder alarm, we have to wait for a closed loop system. So I have something coming out. This is the one slide I ask you not to tweet yet. Can you guys agree to not take a picture? You can take a picture, but don't post this slide yet. Agreed? Okay. So while I was laying around with a broken ankle in January, I was talking to people online, and it occurred to me that there's a lot of great content out there over the last 4.5, 5 years in the DIY community. But if you want to go learn about a DIY closed loop system, if you haven't already picked which one you want to use, you kind of have to go out to a lot of different places to get the knowledge. What can we do to bring all this knowledge into one place and help people understand the basics of APS, whether it was for a DIY system or a commercial system? So I wrote a book that is coming out soon in print. You can technically go online and find it in Kindle. There's a free PDF download, and the web version is live, but the print version's not on Amazon yet, so don't tweet us and be like, oh my gosh, there's a book, because it'll be out in about 2 weeks. It's open source, so if you see typos or you have ideas about content that you want to put in, like the documentation for the APS, it's open source. I'd love for you to give me feedback, tell me what's missing, what questions you have after reading it. But my hope is that this becomes the first place when somebody wants to learn about what is APS, DIY or commercial, how do you get started, how do you understand it, how do you help people who think a pump is already an APS understand the difference with an APS. So that's what that is. I'm hoping it'll be a good starting point. But I will pause there and see if there's any questions, knowing that Adrian's going to talk about the other DIY closed loop systems, and in a couple minutes, Katarina will talk about more research and open stuff.
And we will have opportunity for questions for the three of you once Shane is done.
Perfect. So if there's a question, one or two questions now, happy to take those. If not, we can wait to the end. Yes?
You said your A1C stayed the same, which is to say it was fine before you started looping.
No. My A1C dropped significantly with looping.
Okay.
I'd been looping for 3 years before I switched to no bolus, and my A1C I was very happy with, and I expected it to go up a little bit, and it stayed the same, and I reduced lows, which means that I didn't go as high as I expected, and I reduced the lows, which was great. Yeah.
And your husband, did you find your loved ones find a great difference when you went on to loop? Did they support you and your family support you in doing it? And that, did they notice your mood change? You balanced out your mood without the swings?
Yes. So my now husband and I started dating before we even built the open loop system. But part of the reason we realized we could train a computer is because he really wanted rules. He's like, you're an adult, you've got your diabetes covered, but how do I help? I'm like, well, you can hand me a juice box. And he's like not satisfied with that. He's like, but why are you going low? I'm like, because insulin. And he's like, well, then why are you going high? I'm like, because again, I got the insulin wrong. And so trying to explain to him all the mechanics and giving him the rules of like, if this happens, then that happens. And if you do this in the insulin activity curve, we're like, okay, this is a job better done by a computer. So he was able to get great peace of mind by even seeing my data and better understanding all the mechanics of diabetes. So learning how to build the system actually really helped him understand it. But my family absolutely sees a difference because they know I can sleep safely, and when I sleep, I'm very happy and not grumpy. When I would wake up with a low blood sugar, and I see people laughing like that might be a familiar story for those of us who like to sleep quite a bit, it's a pretty drastic difference. And today, I was telling Katarina the other day, I woke up high for me, which is like 40 points above my normal target of what I wake up, and I can now feel physically a difference when I wake up at 130, whereas I used to feel that if I woke up at like 250. So my body has really recalibrated down. My moods have improved quite a bit, and my family is very happy because I'm traveling around the world, and my husband or my parents or whoever can look at my data and be like, she's awake, she's fine, the system's got her back covered. So even if my blood sugar's going up while I'm speaking, it's dosing insulin responding to that. If I drop because I'm walking to the bus stop, they see it's got me covered. So it's great peace of mind for everybody. So it's really astonishing how much diabetes affects the whole family. And I knew that with my parents, but I didn't realize, obviously, when I fell in love and got married, like how some spouses can be more involved and more deeply in diabetes. They want to be. They want to help because they want to take it away from you, but they can't. So it's been very interesting to see the ripple effect of closed loop on our loved ones as well. So there's a lot of parents in the DIY community who they are able to achieve an okay A1C for their child, like they're at target, but the parent is having to do huge amounts of work and stress and just constant things a day. And I didn't show this, but Solkaharo has this great graph showing how his son was diagnosed at a very young age, and at age 4, they were doing like 5 interventions a day in terms of microboluses or carbs, in addition to the routine stuff. So 5 manual interventions a day, and now with closed loop, they do less than 1 a day, and their son is now 8. Same A1C for them, so much less work. So some people go into it for improved glucose outcomes. Some people, it's for the quality of life for the parents or the family, and not just the child, but the child also sees benefits too. Yeah, great questions. Yes?
Just without being too negative, has anything dangerous happened to you in this time? Anything sailing too close to the wind?
No.
No, that's great.
No, so the great thing is the way we designed the system is that I still have my CGM alarms as backup. So if I did actually go low, I get the, hey, you crossed 80. But for the most part, I get an alarm before saying you're going to go low, but the system would take care of it. So I built the system to give me a ton of alarms, and then closing the loop took away all the alarms. I don't need them except for, in true emergencies. But in the 1 or 2 times that my CGM alarm goes off, I don't have to do anything because the system's already taken away enough insulin, and I'm predicted to come back up. It's just a matter of time. And so we'll talk a little bit more about the safety data and the research that's looking, but we've not seen any major adverse events in the community like that up until recently where it has to do with CGM data. But I personally am very happy, which is why I keep using it and why most people continue to choose. But
Is there sorry,
go ahead.
One last question and then we'll move on.
Yep.
Yes, as we all try and strive to bring down our HbA1c, some of us lose our low symptoms. Being on loop, anytime that you may have ever gone low in those 4 years, do you find that your symptoms are there? Or
I had symptoms all along, but I have heard from some people that they have returned to having hypoglycemia awareness after being unaware because they've got the ability to kind of keep their blood sugar up, and now they feel when they're low. So that's not necessarily, we're not advertising anything. This would not be one of the outcomes, but one of the things that some people see is a return to awareness of hypos, which is, again, not something people expected, but it's kind of interesting to see how that might be true also with commercial APS and longer term usage for more people. Yeah.
Okay. Can we just take a minute before you start?